And number 16, the exponents look odd, but if I wrote this as 3a squared plus 7ab plus 2b squared, you would say, I can work with that. I can do something with it. No problem. Well, it's no different. I just have x's instead of 1's. So I'm still going to look for two terms that multiply to give me 6 and add to give me 7. I'm going to use 1 and 6. Larger number has the sign as that on top. If it's positive on the bottom, they have to have the same sign. So this is 3a to the 2x plus a to the x, b to the x, plus 6a to the x, b to the x, plus 2b to the 2x. So I'm going to group my first two terms together and my last two terms together. I have an a to the x in common. So this is 3. 2x minus x is just x. A to the x, b to the x over a to the x is just b to the x. Carry my middle sign through. Between 6 and 2, I have a 2 in common, and I have a b to the x in common. So 6 divided by 2 is 3. B to the x divided by b to the x cancels out, and I'm left with a to the x. 2 divided by 2 is 1, and b to the 2x over b to the x, that's 2x minus x, so this is b to the x. So now I have 3a to the x plus b to the x in common, and this will be 3a to the x plus b to the x times a to the x plus 2b to the x. In number 17, I'm going to factor out the smaller exponents. So between negative 1/2 and 1/2, negative 1/2 is the smaller. So nothing divides the 4, and this is negative 1/2 minus negative 1/2. So negative 1/2 minus negative 1/2. Well, that's negative 1/2 plus 1/2, which is 0. So this will be y to the 0 power minus, there's nothing that divides the 3, and now I have 1/2 minus negative 1/2, which is 1/2 plus 1/2, which is 1. So this is y to the first power. So this factors into y to the negative 1/2 power times 4 y to the 0 power is just 1 minus 3y. And you can take it one step farther and you can say, okay, this is really 4 minus 3y over y to the 1/2 power, which is 4 minus 3y over the square root of y. Well, then we rationalize the denominator, so multiply both by the square root of y on the top and the bottom, and this gives me the square root of y times 4 minus 3y over y. Number 18, I'm going to factor out the smaller exponent. So k to the 3/4 power is my smaller exponent. So this gives me 4k. I have 7/4 minus 3/4. That's 4/4, which is 1, plus 3k. I have 3/4 minus 3/4, which is 0. So this is k to the 3/4 power times 4k plus 3. And you can write it as the 4th root of k cubed times 4k plus 3. It won't change it, but it doesn't really do anything extra to the problem. Number 19, factor out the smaller exponent. So I have x to the 1/3 power. This is 5x. 4/3 minus 1/3 gives me 3/3, which is 1, plus 2. I have 1/3 minus 1/3, which is 0. So this is x to the 1/3 power times 5x plus 2. And you can write it as the cube root of x times 5x plus 2. It doesn't change it and it doesn't make it wrong. So now, using the same mentality that I've been using, factor out the smaller exponent. Number 20 is like number 10 in the previous video, where it looks complicated, but I'm going to make 3k minus 2 look a little more simple. And I tell you that a is equal to 3k minus 2. So that means I have a to the negative 1/2 power plus 4a to the negative 3/2 power. So now you're going to factor out your smaller exponent. Well, between negative 1/2 and negative 3/2, negative 3/2 is my smaller exponent. So I have a, and it's negative 1/2 minus negative 3/2. Well, that's negative 1/2 plus 3/2. So that's 2/2, which is 1. And I have plus 4, and I have negative 3/2 minus negative 3/2. Well, that's 0. So that means this is a plus 4 over the square root of a cubed. So that means we have a plus 4 over a times the square root of a, because a cubed factors into a times a squared, and a squared is a perfect square. We can't leave that radical on the bottom, so I have the square root of a times the square root of a, and this is the square root of a times a plus 4 over, this will be a times the square root of a squared, which is just a, so I have a squared on the bottom. Now, if you left it here, I'm okay with that. The same thing, if you left this here, I'm okay with that. Up a little ways, here, if you left this answer at this point, that's okay. Or this point, that's okay. You've still done a lot of really good math when you leave it at that point. Okay, so even if you can't get to this point or this point, that's okay. Work towards getting to this point, and then we'll take it from there.